first understand the concept of externality. Thereafter, we will talk about different types of externality, evaluate the problem caused by externalities, learn the solution to externalities problem, understand different solutions given by Pigou and Arrow. In this module, we will discuss another major problem and source of market failure, namely externality. Externality exists when action of any economic agent, whether it be consumers or firms, creates impact on the decision making of other economic agent or agents. We will now proceed to discuss the concept of externalities itself. Externality implies that the economic activity of one consumer or one firm affects the economic activity or activities of other consumers or firms. An externality arises when the production or consumption possibilities of a firm or consumer are influenced by another agent's production or consumption. A consumption externality arises when one consumer cares directly about another agent of production or consumption. By external benefits in consumption, we mean the consumption activities of an individual which increase the welfare of other consumers. For instance, when you consume more education, you are becoming literate. Your neighbors become happy as the number of literate people with whom they can interact increases. Likewise, your well maintained lawn makes the neighborhood look better. External cause in consumption or negative consumption externality occurs when an individual's consumption activities will reduce the welfare of other individuals. For instance, when your neighbor's son plays loud music, your happiness is reduced because of the noise effect. Whenever there exists negative or positive externality, the resource allocation provided by the market will not be efficient. In that case, market fails to reach the optimum when externalities are present in consumption by fulfilling Paretian optimality conditions. Welfare of the community will not be optimized. Welfare can be increased by deviating from the Paretian conditions. Hence, competitive equilibrium by fulfilling Pareto optimal conditions will not optimize welfare. Welfare can be increased by encouraging the consumption of commodities, generating external economies in consumption. We approach the problem from the production side. A production externality arises when the production possibilities of one firm are influenced by the choices of another firm or consumer. As in consumption, there are two types of externalities in production, namely external economies and external diseconomies. Both consumption and production externalities can be positive or negative. The reason why a good or activity becomes an externality is because they do not have a market and no price is associated with them. External economies result when the production activities of firms and industries confer benefits to other activities for which they receive no payments. There are many examples of positive externalities. Suppose a large housing project has developed parks and playing fields in a locality. It also helps other neighbors of the housing project to get fresh air. Therefore, the housing project creates positive externality for others. Another example of positive externality is that of opening of a national highway. It reduces traffic congestion and allows smooth flow of traffic, thereby reducing transportation costs to the users. External economies cause private and social benefits and cost to diverge. In particular, private cost becomes more than social cost, or social benefit exceeds private benefit. The pricing system takes into account only private costs or benefit calculations, while if social cost benefit calculation is taken into account, a different outcome would result. The price of the commodity whose production generates external economies does not provide the correct signal as to the social desirability of the commodity. Since the benefits conferred to others cannot be identified or measured and appropriated, hence cannot be included in the price of the commodity. Therefore, if the social cost in case of negative externality or social benefit in case of positive externalities are not considered in the calculation, efficiency will not hold in decision making and market will fail to provide an efficient solution. Let us briefly introduce external diseconomies in production, which implies that the productive activity of a producing firm imposes costs on other productive firms for which the concerned firm pays no compensation. Most common example of externalities are air and water pollutions. For example, a chemical plant discharges polluted gas in the air. This creates a lot of problems for the nearby farmers. Air pollution increases as the firm produces more and more, and consequently agriculture production reduces more. The production of the chemical plant imposes costs to farmers. The costs imposed on others are not taken into account in determining the price of the commodity based on private cost benefit calculations only. There is no automatic mechanism in the market which can consider the external impacts in the calculations. For this reason, without government intervention, the level of pollution is impossible to control. Generally, proper designing of taxes and subsidies or proper identification of property rights can help the society to internalize the external effects. Let us start with an example of smokers and non-smokers. Suppose there are two roommates A and B. A likes money and smoke. Both money and smoke are economic goods for A. B likes money but hates smoke. For him, money is economic good but smoke is economic bad. Their preferences are represented by an Edgeworth box diagram as shown in the figure 20. OA and OB are origins of person A and B. The amount of money with A and B is measured from the origins at OA and OB respectively or the horizontal axis. The amount of smoke for both A and B is measured vertically from OA. This is because smoke, unlike money, cannot be divided between A and B. Both have to consume smoke in same quantity. Therefore, vertical measurement from origin OB gives the amount of clean air available to both. Note that further away from OB, we are vertically closer are we to OA. Therefore, less is the smoke and more is the clean air in the room. Hence, interpretation of indifference curves also becomes different. For A, indifference curves are downward sloping and convex to the to his origin, that is OA, because both money and smoke are economic goods for him. For B, indifference curves are downward sloping and convex to his origin OB, because both money and clean air are economic goods for him. Clean air increases when smoke decreases. The final outcome and initial endowment here depends on who has the property rights. Let's consider case 1. Suppose B has the right to clean air and both individuals have the same amount. Suppose B has the right to clean air and both individuals have the same amount at point E. Therefore, where EA is equal to rupees 100 and 0 smoke, and EB is equal to rupees 100 and all clean air. Remember, 0 smoke means all clean air. Since B has right to clean air, he can trade it for money. That is, he can allow A to smoke if A pays him money for foregoing his right. Therefore, A and B will trade to the Pareto efficient point F, where marginal rate of substitution of A between smoke and money is equal to marginal rate of substitution of B between smoke and money, and their indifference curves are tangent to each other. At point F, B has allowed some smoke in the room in lieu of money paid by A to him, and both A and B are better off than they were at E. To show this, we must draw indifference curves of A and B passing through point E. These curves intersect each other at point E. By trading, both A and B move to higher indifference curves. Case 2, suppose A has right to smoke and both have the same amount of money, rupees 100. The initial endowment point is E prime, where E of A is equal to rupees 100, smoke filled room, and EB is equal to rupees 100 and clean air. Now, A will trade his right to smoke for money paid to him by B. Now, they will trade and reach final equilibrium at F, which is again a Pareto efficient point, and where both are better off than they were at E. It may be noted that even though F and F prime are both Pareto efficient, they are distributionally different because A is an small a higher indifference curves at F, then he is at F, while it is the reverse for B. Thus, if A and B are free to trade and property rights are well defined, then with any endowment they will end up somewhere on the contract curve of Pareto efficient allocation of smoke and money. Another way to solve their problem would be to create a market for smoke. Under a market mechanism, the competitive equilibrium will be Pareto efficient with externalities arising if property rights are not well defined. Under such circumstances, inefficient amount of externality gets generated and there is no scope of trade because of poorly defined property rights. We will now talk about quasi-linear preference and the Coase theorem. In the previous example given well defined property rights, two main points should be noted. First, the final outcome of trade will be Pareto efficient. Second, the final amount of externality generated will depend on who has the property rights. There is more smoke at F prime when rights are with smoker at E than at F when rights are with non-smoker at E. But if preferences of both A and B are quasi-linear, then the final amount of externality generated becomes independent of the assignment of property rights. Thus, every contract curve has the same amount of externality.
With quasi-linear preferences, IC-S are just vertically shifted versions of same IC for both A and B. Thus, the points of tangencies between the IC-S of A and B will be on a horizontal line. Thus, the contract curve will be a horizontal line, and every Pareto to efficient allocation will have the same amount of smoke but different amounts of money distribution between A and B. Thus, Coase theorem says under certain conditions the efficient amount of an externality is independent of the distribution of property rights. These certain conditions are no income effects, that is, for quasi-linear preferences, income effect is zero.
We have to remember that in this case, even though the amount of externality generated is independent of distribution of wealth and property rights, the individuals are not indifferent between them. Here like f prime to f, because he has more money and hence is on a higher indifference curve at f prime than at f. By the same logic, B would prefer f to f prime. Let us now consider a situation involving production externalities. A steel firm produces steel S and also some pollution P. We are denoting steel by S and pollution by P, which is dumped into the river. A fishery is located downstream and it gets adversely affected by this pollution.
Cost function of steel firm is equal to CS SP, where DCS SP upon DS is greater than 0 and DCS SP upon DP is less than 0. Cost function of fishery is equal to CF FP, where DCF FP upon DF is greater than 0 and DCF FP upon DP is greater than 0. Thus, pollution becomes a negative externality for the fishery because it affects the cost of fish production F adversely, but the fishery has no control over it. Thus, when the steel mill and fishery operate independently, the final outcome would be the steel mill's profit maximization problem is max SP pi s is equal to ps dot s minus cs sp. Profit maximization conditions are d pi s by ds is equal to 0, that is ps minus dcs sp upon ds is equal to 0, that is ps is equal to dcs s star p star upon ds d pi s upon dp is equal to 0, that is dcs s star p star upon dp is equal to 0. The steel firm's equilibrium is S star P star. The fishery takes P star as given level of pollution and its profit maximization problem is max F pi F is equal to PF dot F minus CF F P star. The profit maximization conditions are d pi f upon df is equal to 0, pf is equal to dcf f star p star upon df. The externality here arises because of the fact that the pollution being generated by the steel firm affects the fishery, but the fishery has no control over it. The steel firm, while producing, takes only its private cost into account and, by definition, the price of pollution it faces is zero. The steel firm ignores the social cost of pollution, which, in this case, leads to increase in cost of fishery. The merged firm's profit maximization problem is max SFP pi is equal to PS dot S plus PF dot F minus CS SP minus CF FP. The profit maximization conditions are d pi upon ds is equal to 0, ps minus dcs sp upon ds is equal to 0, ps is equal to dcs s hat p hat upon ds. This is equation 1. d pi upon df is equal to 0, pf minus dcf fp upon df is equal to 0, pf is equal to dcf f hat p hat upon df. This is equation 2. d pi upon dp is equal to minus dcs sp upon dp minus dcf fp upon dp is equal to 0. Minus dcs s hat p hat upon dp is equal to dcf f hat p hat upon dp. This is equation 3. And the equilibrium is s hat f hat p hat. Equation 3 shows that the merged firm does not take the price of pollution as 0. Instead, the price of pollution is taken as the cost this pollution imposes on the fishery. Therefore, steel firms takes social cost of its action into account. When the steel firm acts independently, it takes price of pollution as 0 and accordingly produces P star where MCS S star P star is equal to 0 or DCS S star P star upon DP is equal to 0. The merged firm, on the other hand, produces pollution till the point where marginal cost to steel mill is equal to marginal cost to fishery, that is, at S hat P hat, where minus MCS S hat P hat is equal to MCF F hat P hat. Since MCF of pollution is positive, therefore the steel firm will produce pollution till the point where minus MCS is equal to MBS, marginal benefit to steel firm, is greater than 0. Given a downward sloping minus MCS SP curve, P hat is less than P star, since at P hat minus MCS S hat P hat is greater than 0, while at P star MCS S star P star is equal to 0.
Pareto efficient level of pollution in we will consider the two firms as a single entity, firm that produces both steel and fish. By doing this, we have internalized the externality. This is because by merging the firms, we have ensured that the steel firm will take into account the impact of its actions on the fishery, since both are part of the same firm. In the diagram, the profit maximizing independent steel firm produces pollution till the point where marginal benefit from an extra unit is equal to 0 at P prime. On the other hand, the Pareto efficient level of production is produced till the point where marginal benefit to steel firm is equal to marginal cost to the fishery. Thus, due to divergence between private and social cost, the good generating externality gets overproduced under the free market. Now, we will talk about the solution to the externality problem. Three solutions have been given for externality problem. Those are Coasean solution, well defined property rights and costless bargaining. The Pigouvian solution, put a tax on the production of good generating externality, and Arovian solution, create a market for the externality through well defined property rights, and prices will automatically ensure optimal generation of externality. In the Coasean solution, if property rights are well defined and there is costless bargaining, then the two agents involved would bargain and reach the Pareto optimal level of pollution. We will talk about case 1 in this, property rights with steel mill. When the steel mill has the property right to generate as much pollution as it wants, it will produce P prime units of pollution. At P prime, marginal benefit of steel is equal to 0, while marginal cost of fishery is equal to Cp prime. Since steel firm has property rights, the fishery will bargain with the steel firm to reduce the P prime unit of pollution. The fishery will make a payment to the steel mill such that the marginal benefit of steel is less than the payment made. That therefore, for the pollution unit, some payment like C1 will be made by the fishery to steel mill, and the P prime unit of pollution will not be produced. In case 2, property rights with the fishery, in this case initial pollution production would be at 0 and the steel mill will pay the fishery to produce pollution. Here again, through bargaining, the final pollution production would be increased from O to P. The final payment made by each additional unit of pollution would be such that marginal cost of fisheries is less than the payment made to fisheries. Thus, irrespective of who has the property rights, as long as property rights are well defined and bargaining is costless, the final production of pollution would be at the Pareto optimal level P. In the Pigouvian solution, one way to bring pollution to the efficient level P is to place a tax on pollution generated by the steel mill. This will make sure that the polluter faces the correct social cost of its actions.
Suppose we put a tax of T per unit of pollution generated by steel mill. Thus, the profit maximization problem of steel mill becomes max pi is equal to Ps dot S minus Cs Sp minus T dot P. The profit maximization conditions become d pi upon dp is equal to 0, Ps0 minus dcs Sp upon ds is equal to 0, Ps dcs Sp upon ds. D pi upon dp is equal to 0 minus dcs Sp upon dp minus t is equal to 0 minus dcs Sp upon dp is equal to t. If we want p is equal to p hat, then form socially optimal condition t is equal to dc dash s hat p hat upon dp. This particular level of tax is known as a Pigouvian tax. Diagrammatically, it can be represented as shown in the figure. Minus MCS and MCF represent the marginal benefit and marginal cost of pollution to steel mill and fishery respectively. If a Pigou tax of T is equal to dcs S hat P hat upon dp is imposed, the marginal benefit to steel mill of every unit of pollution reduces by T. Therefore, the minus MCS curve shifts parallel inwards by T to minus mc dash s. It can be seen from figure that the post-tax marginal benefit of pollution becomes zero at the level p hat instead of the original p star. Thus, the steel mill, which produces pollution till the level where minus mcs is equal to 0, will post-tax generate p hat level of pollution which is social optimal.
The problem with the Pigouvian text is that we need to know the optimal level of pollution and the marginal cost and marginal benefit associated with that to impose the tax. But if we know the optimal level of pollution, then we do not need the tax at all. We can just tell the steel mill to directly produce that much pollution. In the Arrovian solution, the problem of externality arises because there is a missing market for pollution, because of which the steel mill faces a zero price for pollution produced by it, even though the fishery would be willing to pay to reduce pollution levels. Thus, if we define property rights and allow buying and selling of pollution, the externality problem would be solved and we get the socially optimal level of externality.
Case 1, suppose fishery has right to clean water. Now, fishery would be selling right to pollution to the steel mill. If Q is the price per unit of pollution and P is the amount of pollution that the steel mill produces, it buys right to produce P units of pollution at a price of Q per unit from fishery. Therefore, the steel mill's profit maximizing problem is max pi s is equal to ps dot s minus cs sp minus q dot ps p. Q dot p is additional cost for steel mill, while the fishery profit maximizing function looks like max pi f is equal to pf dot f minus cf fp plus q pf p. Q dot p is additional revenue for fishery. The profit maximizing solution for steel mill and fishery are d pi s upon ds is equal to 0, ps minus dcs sp upon ds is equal to 0, ps is equal to dcs sp upon ds. This is equation 1. D pi s upon dp is equal to 0, ps minus dcs sp upon ds minus q is equal to 0, ps is equal to minus dcs sp upon ds is equal to q. This is equation 2. D pi f upon df is equal to 0, pf minus dcf fp upon df is equal to 0, pf is equal to minus dcf fp upon df. This is equation 3. D pi f upon dp is equal to 0, minus dcf fp upon df plus q is equal to 0, dcs fp upon dp is equal to q. This is equation 4. The market for pollution will clear if dp and ss balance. dp price is determined by equation 2 while ss price is given by equation 4. Therefore, at equilibrium, minus dCs Sp by dP is equal to dCs Fp by dP. This is exactly the same condition as was derived for socially optimal production of pollution. Case 2. When the steel mill has right to pollutions. Now, the fishery pays the steel mill to reduce pollution. Suppose, without any interaction with the fishery, the steel mill is producing P star units of pollution. Now Q becomes the price per unit of pollution reduced. Now the profit maximizing problems of steel mill will become max pi s is equal to ps dot s minus cs sp plus q into p star minus p. Note, q into p star minus p is revenue earned by reducing pollution from p star to p, while the fisheries profit maximization problem is max pi f is equal to pf dot f minus cf fp minus q into p star minus p f p. Note, q into p star minus p is extra cost due to payment made to steel mill to reduce pollution from p star to p. Here again, the profit maximizing conditions are d pi s upon ds is equal to 0, ps minus ds sp upon ds is equal to 0, ps is equal to dcs sp upon ds. This is equation 1. d pi s upon ds is equal to 0, ps minus dcs sp upon ds minus q is equal to 0, dcs sp upon dp is equal to q. This is equation 2. d pi f upon df is equal to 0, pf minus dcf fp upon df is equal to 0, pf dcf fp upon df. This is equation 3. d pi f upon dp is equal to 0 minus dcf fp upon df plus q is equal to 0, dcs fp upon dp is equal to q. This is equation 4. Therefore, these conditions are exactly the same as what we have when property rights are with fishery. Thus, irrespective of who has the property rights, the market will generate optimal amount of externality, even though distribution of benefit will depend on who has the property right.
We will now talk about the tragedy of the commons. This refers to the inefficiency that arises when property rights are not well defined. We consider a common field in a village where villagers graze their cows. Cost per cow is equal to rupees A, that is MC is equal to AC. Value of milk produced by cows is a function of C, that is average product per cow and the marginal product of each cow.
We consider two situations. Suppose there is private ownership of common ground. Then the individual will maximize his total wealth, which in turn would mean maximization of wealth of the village. Therefore, his maximization problem is max.fc minus AC, and maximization will occur where MP into C star is equal to A. The individual would buy C star number of cows. Suppose there is common owners of ground. Now, when a villager decides to add a cow to the common, his decision will be based on the fact whether the output generated by the cow is greater or lesser than its cost. Suppose currently C cows are grazing and AP is equal to FC upon C. Adding another cow would be profitable from a villager's point of view as long as F C plus 1 upon C plus 1 is greater than or equal to A. Hence, the villagers will graze cows till the average product of a cow is equal to A. Therefore, C hat cows will be grazed where F C hat upon C hat is equal to A, F C hat is equal to A C hat, which gives us F C hat minus A C hat is equal to 0. That is total profit. Profit maximization has been driven to 0. This happens because an individual villager ignores the social cost of his action. When an individual decides to add a cow to the common, he only considers the private cost A of buying the cow. He ignores the fact that his extra cow will reduce output of all existing cows. Thus, each villager ignores the social cost of his action and the common ground gets overgrazed.
We can see through the diagrams here ideally number of cows should be E where MP is equal to MC, but actually C prime cows graze on the ground because actual number of cows is where AP is equal to AC. To prevent overgrazing of field, we need some mechanism to restrict use. One such mechanism is private property as shown in case 1 above. If ownership of ground is given to an individual, number of cows grazed would be maximizing profit. Government can take out grazing rights and sell them. The number of grazing rights would be C prime. Government can impose a per unit tax per cow. We can summarize the above discussion. Externality is one of the main reasons of market failure. The major source of inefficiency lies in the existence of externalities. As externality arises when a person engages in an activity that influences the well-being of another individual and yet neither pays or receives any compensation for these effects. Externalities are borne by people who are not directly involved in the market exchanges. Thus, an externality is a divergence between private costs and social costs or between private benefits and social benefits. When externalities are present, the outcome of a competitive market is unlikely to be Pareto efficient.